Hey guys, it's Miss Johnson and I'm here to bring you our notes video for Unit 3 Notes 3. Today we're talking about multiplying monomials. So before we talk about multiplying monomials, we should probably figure out what is a monomial. A monomial is a number, a variable, or a product of a number and one or more variable. Monomials with no variables are called constants. So that's a definition for you. Let's just look at some examples. A constant, which we all are familiar with that term, we've seen that before, would be something like 2 or 4 or 7. A variable, we know what variables are. They're letters, X, Y, Z, A, B, M, N. The product of a constant and one or more variables, something that looks like 2A. Now, it's deceiving because that looks like that's two different things, but it's actually only one. This is actually one term, one monomial. Another example would be something like 3xy, still only one term. Same thing with like q squared rs. That's a product of all variables, but it's still only one term. So one thing that we should probably note is that, and we talked about this yesterday a little bit, is that monomials are separated by addition and subtraction. Separated by addition and subtraction. We talked about this with terms yesterday. Terms are separated by addition and subtraction. So monomial, that's what we're looking at today. Now we've got some rules when we multiply these things. When we multiply powers, we've got a bunch of different rules that we need to remember. The first one is the product of powers rule when we're multiplying two powers. Okay, multiplying powers. When we multiply powers, we actually are going to add the exponents. So the base doesn't change, but we add the exponent. Oh, that's what I wanted to write. Base doesn't change. So for example, if I look at something like a to the 6th times a to the 3rd, my base is still going to be a, but now I multiply these out and I get a to the 9th. This is kind of like saying a times 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 a. That's a to the 6th, that's a to the 3rd. If you put them all together, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. That's a to the 9th power. So my base didn't change, but my powers were added. If I take a look at the next one is power of a power. This is when you have something in parentheses with a power outside, like let's say to the 3rd power. Okay, so for that rule, power of a power, we multiply the exponents. And again, the base is not going to change, but we're going to multiply the exponents together. Now here's where that comes from. If I look at 6a to the 6th, all raised to the 2nd power, it's kind of like saying this power of 2 that's on the outside goes to both things on the inside. So I have to consider what is 6 to the 2nd, and I also have to consider what is a to the 6th to the 2nd. Well, 6 to the 2nd is 6 times 6, and a to the 6th to the 2nd is a to the 6th times 2. I multiply those together. And when I do that, we all know 6 times 6 gives me 36, and a to the 6th to the 2nd is a to the 12th. The other way I can think of this power of powers rule, just because it's kind of confusing sometimes, if I have 6a to the 6th all raised to the 2nd power, that's the same thing as saying I have 6a to the 6th multiplied by itself 2 times. Oops, parenthesis over the whole thing. So really, when I look at this, I'm multiplying 6 times 6, which is 36, and I'm taking a to the 6th times a to the 6th, which is a to the 12th, because we add the exponents when we multiply powers. So either way you think about it, you get the same answer. It's 36a to the 12th. The last rule of exponents that we're going to talk about today is the 0 power rule. When we have any number raised to the 0 power, it equals 1. That's it. But the thing we have to consider is that it's only the part that's raised to the 0 power equals 1. So this one, the variable disappears. or I should say the base, whatever the base may be, disappears. Okay, so if I have a 10,000 times a to the third, all raised to the 0 power, meaning the 0 power is going to the 10,000 and to the a to the third, this whole thing is just going to equal 1. All of this goes away. Anything raised to the 0 power is equal to 1. The base is gone. The base of a is gone. It's all just 1. So let's put some of those rules into practice. One thing that we have to consider when we simplify monomials is we've got a little checklist here. Here's our checklist that we have to think about. There's 3 things on it. The first one is we have to see each base only one time. Okay, that's kind of like saying each variable. We see each variable only one time. Another thing to consider is that there are no power of powers, or in other words, no more parentheses. All parentheses have been taken care of. And the last one, all fractions need to be in simplest form. So just like we would reduce a fraction if it were alone, when the fraction has some variables with it, we still need to reduce it. We need to make sure it's in simplest form. All right, so let's take a look at number 1. If I take a look at number 1, I have 4 times x squared times y to the third. Now that's a monomial, even though it has a bunch of different things in it, because I have no addition or subtraction. So I need to combine some things here. One problem that I see is I have x written twice. I have x times x squared. Well, consider that when there's no exponent written, it's x to the first power. If I put these x's together, 1 plus 2 gives me 3. So that's 4x to the third, y to the third. Now I see the x one time, I see the y one time. That's not a fraction, so I don't need to worry about simplifying it, and I'm done. In number 2, remember that between 2 sets of parentheses, if you don't see an operation, that means it's multiplication. So these things are actually being multiplied together. Put the like parts together, and you can even rewrite it if it will help you. If I rewrite this, putting my like parts together, I have 3 times 2 times x squared times x to the fourth times y to the first times y to the eighth. Okay, so I put my like terms together. So this is a group, and this is a group. Those have to all be combined. 3 times 2 gives me 6. X to the second times x to the fourth, add those powers together, that's x to the sixth. And y to the first times y to the eighth, add those powers together, that's y to the ninth. Now, one common mistake that I see people make is they forget about that power of 1 and they don't add it to the 8. So I have to actually make sure that I account for that power of 1 and combine it. That's my simplified form. No fraction to reduce, only one x, only one y, everything's simplified. Here we go. Let's take a look at number 3. Easy peasy. These 2 examples, both of them, 3 and 4, should take you about 1 second. Everything inside is being raised to the 0 power. 4 to the 0 power, x to the 0 power, y to the 0 power, z to the third to the 0 power. All of it is raised to the 0 power. It all goes away, and your answer is 1. In number 4, same thing. It's all being raised to the 0 power. It all goes away, and your answer is 1. That makes life pretty easy. Let's try number 5. In number 5, we have 4xy squared raised to the second power. So a couple of ways you can think about this. One way is the power of 2 that's on the outside goes to all 3 parts inside. Or you think about it as 4xy squared times itself 2 times. Now, it's not so bad to write it out when you're only writing it out 2 times, but if you have to write it out like 10 times, it's helpful to know that rule that everything inside goes to the second power and that your exponents get multiplied together. So if I think about it that way, 4 to the second power is 16. X to the first to the second, 1 times 2 is 2. So that's x squared. Y to the second, 2 times 2 is 4. That's y to the fourth. There's my simplified expression. If you look at writing it out 2 times and then simplifying, 4 times 4 still gives me 16. X to the first times x to the first gives me x to the second. Y to the second times y to the second. 2 plus 2 gives me 4. That's y to the fourth. I got the same answer. Let's try to number 6. I'm going to take that power of 4 and distribute it to each thing inside. So I have 2 to the 4th power, x to the 1st to the 4th power, which is 1 times 4, and y to the 1st to the 4th power, which is 1 times 4. 2 to the 4th power, that is not 2 times 4. Let me say it again. 2 to the 4th power, I'll even have you write it down. 2 to the 4th power is not 2 times 4. 2 to the 4th power is not 8. If you plug it into your calculator, 2 to the 4th power is in fact 16. These two are common mistakes. They happen all the time. Please be smarter than that. I know you can think about it in a different way. 2 to the 4th is equal to 16. So I have 16 here. Then I have x to the 1st to the 4th. That's x to the 4th. Then y to the 1st to the 4th. That's y to the 4th. And there I am. All right, I'm going to go ahead and stop our video there today. We'll come back and finish up the rest of our examples on the back tomorrow. Thanks for watching and have a great night.